Hello, thanks for joining us today. It is great to meet you. I have your resume here, and I see you are a recent graduate. We are looking for someone who has a strong grasp of the fundamentals of Angular and is eager to grow within our team. How are you doing today?
I am doing great, thank you so much for having me. I am really excited about this opportunity. I have spent a lot of time during my studies and my personal projects diving deep into Angular, and I am looking forward to discussing how I can apply that knowledge here.
That enthusiasm is great to hear. Let us jump right in. I like to start with the basics to get a feel for how you think. In your own words, what is the basic purpose of an Angular component?
Right. So, the basic purpose of an Angular component is to act as a self-contained building block of the user interface. If you think about a modern web page, it is rarely just one big file. Instead, it is made of many smaller pieces. A component combines three main things: a template for the layout, which is the HTML, a class to handle the logic and data, which is the TypeScript part, and styles for the appearance using CSS. By breaking a page into these small components, developers can manage complex apps much more easily. It also makes the code reusable, so if I build a specific button or a navigation bar as a component, I can use that same piece of UI in different parts of the application without rewriting it.
That is a solid explanation. Now, to make those components actually work, you need to define them in the code. Which decorator do you use to tell Angular that a class is actually a component?
You use the component decorator. You place it right above the class definition. It is essentially telling Angular, hey, this specific class should be treated as a component. The decorator is where you provide the essential metadata. For example, you specify the template it uses, the CSS styles that apply to it, and a unique selector. That selector is what allows you to call the component in other HTML files, like using a custom tag.
Perfect. Now, once you have a component, you need to get data from your TypeScript logic onto the screen. Could you explain what interpolation is and how it differs from property binding and event binding?
Sure. Interpolation is probably the most common way to display dynamic data. It uses those double curly braces in the HTML template. Basically, it takes a variable or a small piece of logic from the TypeScript class, converts it into a string, and puts it directly into the text of the page. It is really for showing text. Property binding is different because it does not target the text content. Instead, it sets a specific property of an HTML element or a component. You use square brackets for that. For example, if you wanted to disable a button based on a Boolean variable in your logic, you would use property binding on the disabled attribute. Then there is event binding, which is almost the opposite in terms of flow. While interpolation and property binding move data from the logic to the view, event binding is one-way communication from the view back to the logic. You use parentheses for this, like in a click event. It triggers a function in your TypeScript class when a user does something, like clicking a button or typing in a field. So, in short, interpolation is for showing text, property binding is for controlling element settings, and event binding is for handling user actions.
That is very clear. Moving along, you mentioned the logic and the view. One of the biggest parts of Angular is how it organizes these pieces. What is the role of the ngModule?
I think of an ngModule as a container or an organizational box for the application. Its main role is to group together related components, directives, pipes, and services so that Angular knows how they all relate to each other. It tells the framework which pieces of code belong together and which external tools or other modules are needed for those pieces to work. By organizing the app into modules, we can keep the code clean. A big advantage is that it allows for lazy loading, meaning you can choose to load certain parts of the app only when the user actually needs them, which makes the initial application start much faster.
Since you mentioned components and their organization, let us talk about the lifecycle of a component. How does Angular manage that?
Angular manages a component's lifecycle through a series of lifecycle hooks. These are special methods that the framework calls automatically at specific moments in a component's existence. It is like a timeline that starts when the component is created and ends when it is destroyed. The framework handles the timing of these events. For instance, it knows when the component is first initialized, when data bound to the component changes, or when the component is removed from the screen. By using these hooks, we can run custom code at the exact moment something happens. For example, we might use a hook to fetch data from a server as soon as the component is ready, or we might use one to clean up timers so we do not have memory leaks.
Speaking of that, if you specifically want to detect when a component has been initialized, which hook would you use, and why not just use the constructor?
To detect when a component has been initialized, you use the ngOnInit lifecycle hook. Angular calls this automatically once the component has been created, and importantly, after all the input properties have been set. The reason you should not use the constructor for this logic is that the constructor is meant for simple dependency injection. At the moment the constructor runs, the component's input properties are not yet available. If you try to use an input variable in the constructor, it will likely be undefined. So, ngOnInit is the best place to put logic that needs to happen at the start, such as calling a service to fetch data from a server or setting up initial variables.
Good distinction. And on the other end of the spectrum, what about when the component is leaving? What does the onDestroy lifecycle hook allow you to do?
The onDestroy hook is called right before a component or directive is removed from the screen and destroyed. It is essentially your cleanup phase. This is where you perform tasks to prevent memory leaks and unexpected behavior. Typically, this is where I would stop any active timers, unsubscribe from observable data streams, or detach event listeners that were created manually. If you do not do this, the application might keep running processes in the background for a component that no longer exists, which can really slow down the app over time.
Let us shift gears to data handling. Most apps need to talk to a server. What is the purpose of the HTTP client module, and what does it provide?
The HTTP client module is a built-in Angular module that provides a set of services for making network requests. Its primary purpose is to simplify the process of sending and receiving data via HTTP protocols, like GET, POST, PUT, and DELETE. Under the hood, it wraps the browser's native Fetch API or XML HTTP request. What is really powerful is that it returns the data as observables. This allows us to use the RxJS library to handle asynchronous data streams. It makes it very easy to implement things like timeouts or to retry a failed request if the network blips, which would be much more tedious to do with standard promises.
You mentioned observables. That leads me to a more technical question. In RxJS, what is the fundamental difference between an observable and a promise?
The main difference is that a promise handles a single event, and then it is finished. Once a promise resolves or rejects, that is the end of it. An observable, however, can handle a stream of multiple events over time. There is also the difference in execution. A promise is eager, meaning it starts executing as soon as it is created, and you cannot cancel it once it starts. An observable is lazy. It does not start emitting data until you explicitly subscribe to it. And if you want to stop receiving data, you can simply unsubscribe. Finally, in terms of data, promises only provide a single value or an error. Observables can emit 0, 1, or many values. They also come with a huge set of operators that let you filter, transform, or combine the data before it ever reaches the subscriber, which is incredibly powerful for complex data flows.
That is a great explanation. Since you are comfortable with observables, let us get into the specifics of RxJS subjects. Could you discuss the difference between a subject, a behavior subject, and a replay subject, and give me an example of when you would use each in a service?
Sure. In RxJS, a subject is a special type of observable that allows values to be multicasted to many observers. The key difference between the three is how they handle the history of the values they emit. A standard subject is like a live broadcast. If you subscribe late, you miss everything that happened before you joined. You only get the values emitted after the moment of subscription. In a service, I would use a standard subject for one-time events that do not need a history, like a button-click event that triggers a notification. A behavior subject is more like a state variable. It requires an initial value, and it always gives the most recent value to any new subscriber immediately upon subscription. This is perfect for application state. For example, if I have a service that stores the current user profile or a theme setting, I would use a behavior subject so that any component loading in can immediately know the current state of the user. Then there is the replay subject, which is like a DVR recording. It can store a specific number of previous values and play them back to any new subscriber, regardless of when they join. I would use this for a stream of events where the sequence of a few recent actions is important. For example, if I want a new component to see the last 3 search queries the user made to provide suggestions, a replay subject would be the right choice.
Very well put. Now let us talk about the communication between the app and the server. Can you explain the relationship between HTTP client interceptor and API calls?
An HTTP client interceptor acts as a middleman between the Angular application and the backend server. Whenever you make an API call using the HTTP client service, the request does not go directly to the server. Instead, it passes through a chain of interceptors. These interceptors can see the request, modify it, or even block it entirely before it ever leaves the browser. For example, a common use case is adding an authentication token to the headers of every single request, so you do not have to manually add it in every service method. Similarly, when the server sends a response back, the interceptor catches that response first. This allows you to handle errors globally. For instance, if the server returns a 401 unauthorized error, the interceptor can catch that and automatically redirect the user to the login page, regardless of which component made the request. It is a great way to separate cross-cutting concerns, like logging and authentication, from the actual business logic.
I like how you used a real-world example there. Let us talk about testing. Imagine you have a complex service that depends on an external HTTP endpoint. How would you approach testing this to ensure the tests are isolated and fast?
To test a service without relying on a real server, I would use the HTTP client testing module provided by Angular. This is crucial because it allows me to replace the actual HTTP backend with a mock system. I would use the HTTP testing controller to intercept the requests made by the service. With this, I can provide fake responses. This ensures the tests are isolated because they do not depend on network stability or the actual data on the server, and they are fast because no real network calls are actually happening. In my test setup, I would focus on how the service handles different scenarios. I would manually trigger a successful data retrieval to see if the service parses the data correctly, but I would also trigger API errors or empty responses to make sure the service handles those edge cases gracefully without crashing the app.
That sounds like a very professional approach to testing. Now let us move into some more advanced topics. Let us talk about performance. When dealing with large datasets in an Angular app, what strategies should be employed to optimize performance and prevent memory leaks?
When handling large datasets, the primary goal is to reduce the number of DOM elements and manage memory effectively. First, I would use virtual scrolling. Instead of rendering a list of 1,000 items, virtual scrolling only renders the items currently visible in the viewport. As the user scrolls, the items are swapped out, which keeps the DOM light. To improve rendering speed, I would use the trackby function in for loops. By default, if a list changes, Angular might re-render the whole thing. With trackby, I can tell Angular to use a unique ID to track each item. If only one item in the list changes, Angular only updates that specific element instead of rebuilding the entire list. To prevent memory leaks, I am very careful with observables. I always unsubscribe from them. I prefer using the async pipe in the template because it manages the subscription and unsubscription automatically. If I cannot use the async pipe, I would use the takeUntil operator with a subject that emits in the onDestroy hook. Finally, I would use the onPush change detection strategy. This tells Angular to stop checking for changes in a component unless its input properties change or an event is explicitly triggered, which significantly reduces the number of checks the framework has to perform.
You mentioned on-push and change detection. Could you go deeper into that? How does Angular's change detection mechanism actually work under the hood?
Under the hood, Angular uses a system of change detectors that mirror the component tree. Basically, for every component in the app, there is a corresponding change detector. When an event happens, like a button click, a timer finishing, or an API response coming back, Angular triggers a check. It then compares the current values of data-bound properties with their previous values. If it finds a difference, it updates the specific part of the DOM that depends on that data. By default, Angular uses a strategy where it checks every component from the top down whenever any change occurs. While this is reliable, it can become a performance bottleneck in very large apps. That is why onPush is so useful, as it allows us to tell Angular to skip entire branches of the component tree if the data hasn't changed.
That is a very clear technical explanation. Let us pivot to forms for a moment. In Angular components, what is the role of the Forms module?
The Forms module is a built-in module that provides the tools to handle user input. Its primary role is to enable two-way data binding. This means any change a user makes in an input field is immediately updated in the component's TypeScript logic, and conversely, any change in the logic is immediately reflected in the input field. It also provides directives like ngModule. This allows us to track the state of a form, such as whether a field is valid, whether the user has touched the field, or if the value is dirty. It basically simplifies the bridge between the HTML form elements and the data models in the class.
I have a specific scenario for you. Imagine you have a deeply nested form structure. You need to implement custom cross-field validation logic that requires access to sibling form controls. How would you do that?
For cross-field validation between siblings, the key is to apply the validator to the common parent form group rather than the individual controls. Because Angular validators receive the control or group they are attached to as the first argument, a validator placed on the parent group has full access to all its children through the controls. Object. For example, if I have a password and a confirm password field, I would put the validator on the group that contains both. Whenever a value in either child control changes, the parent group automatically revalidates. The custom function can then compare the values of the two siblings and set an error on the group or a specific child control if they do not match. To keep this from becoming repetitive in deep nests, I would create a reusable validator factory that takes the names of the sibling controls as arguments, making the logic generic and easy to reuse. Across the app.
That is a very sophisticated answer. Now let us go back to the service layer. Imagine you have a complex component with multiple data sources updating asynchronously. How would you architect the service layer to consolidate, debounce, and process these inputs efficiently?
In that case, I would implement a state management service that acts as a central hub using RxJS. I would not let the component handle the raw API calls directly. Instead, the service would use operators like merge or combine latest to unify the various data streams into a single state object. To prevent the UI from overloading and performing too many updates, I would apply a debounce time or audit time operator to the combined stream. This ensures that the UI only updates after a short period of stability, which is much better for performance. I would then expose this final process data as a single observable. This allows the component to subscribe just once and use the async pipe to manage the data flow and automatic cleanup. This way, the component stays thin and only cares about displaying the data, while the service handles all the complex coordination and timing.
You seem very comfortable with RxJS. One common issue developers face is infinite loops when subscribing to observables. How can you prevent those?
Infinite loops usually happen when a subscription triggers a change, and that change then triggers the same subscription again, creating a cycle. To prevent this, one of the best tools is the distinct-until-changed operator. This ensures that the observable only emits a value if it is actually different from the previous one. If the value is the same, it doesn't trigger the subscription again. Another way is to use a subject combined with the take-one operator, which ensures the subscription completes after the first single value is received. I also make it a rule to avoid placing subscriptions inside lifecycle hooks like ngDoCheck or inside setters that trigger the same data update. As I mentioned before, using the async pipe in the template is often the safest approach because it is integrated with Angular's change detection cycle and manages subscriptions automatically.
It sounds like you have a very strong theoretical foundation. Since you are a fresher, I want to know how you handled the learning curve. If you were stuck on a bug in a large codebase and the documentation wasn't helping, what would your process be?
Since I am just starting my professional journey, I know I will encounter things I don't understand. My first step is usually to isolate the problem. I try to create a minimal reproducible example of the bug in a separate small project to see if it is an Angular issue or a logic issue in the specific codebase. If that doesn't work, I dive into the community. I check Stack Overflow and the GitHub issues for the specific library I am using. I also find that reading the source code of the library itself, if it is open source, can be very revealing. Once I have a few theories, I would document what I have tried and then approach a senior developer. I don't want to just say I am stuck. I want to say I am seeing this behavior, I have tried X and Y, and I suspect the issue is here. I think that shows I am taking ownership of the problem and respect their time.
That is exactly the kind of mindset we look for. To wrap things up, do you have any final thoughts or a specific project you worked on that you are particularly proud of?
I actually worked on a project during my final semester where I built a small task management dashboard. I used everything we talked about today, including behavior subjects for state management and custom validators for the task input forms. I spent a lot of time optimizing the list rendering using trackby and virtual scrolling because I wanted to see how the app performed with thousands of dummy tasks. It was a great way to move from theoretical knowledge to actually seeing how the framework behaves under stress. I am really eager to bring that curiosity and drive to a professional team.
It sounds like you have put in a lot of work. I appreciate the detail in your answers today. You have a very strong grasp of the Angular ecosystem for someone at the start of their career. We will be in touch soon regarding the next steps.
Thank you so much for your time. I really enjoyed the conversation. I look forward to hearing from you.